I want your input on something about the STAT course and also about what's going on with the use of data analysis in schools. Because as you know, that's something I'm very interested in. I've never been able to quite figure out why we don't do a better job with that in schools. So I'm going to show you two different ways of doing that. And I'm thinking about this in terms of switching over to teaching people how to use Excel for data analysis. One, because I think maybe if people had access to that or realized that they could do this, they would analyze more data. But two, if you learn how to do that, you would also realize you get to the point that you have access to this all the time once you learn how to do it. And you wouldn't have to go back and worry about having to find SPSS once you're out of the program, because for Excel, this is always just sitting there. It's just I've never taken the time to really work with it. So I'm going to pose a couple of questions when this is over with, but I want to show you kind of what the difference is with this. So first of all, what we have is a set of pre-test data, midterm, and post-test data, and we're going to do a repeated measures ANOVA. We want to know if this works, if we're making any difference. So in SPSS, there's a few buttons that we're going to click. And I've already set this up for 3 factors. I've moved my variables over to here. I have my options for descriptive and estimates of effect size. Plots, we got that set up. And the means, I've got my post hoc analysis set up using Bonferroni. I hit OK. So with SPSS, we can go through here, find out what our mean scores are at each point. We did not violate the sphericity, and this is going to be an issue with Excel because it can't do this. We have a significant difference. We have an effect size. We have pairwise comparisons. And then we have this nice plot that shows what has happened in our scores. So that's the SPSS version of this. Excel can kind of do this too. It's just not quite as intuitive. So again, I've got this data set up. So I want to do a repeated measures ANOVA here. So, well, first of all, to do this, you go into your options, go to the add-ins, and what you want to do, and I've already moved them, is this analysis tool pack and analysis tool pack VBA will be down here in the inactive. You click on it and you go to manage this, and basically what you're doing is just moving it up so that you can use it. So I've got this data. I want to analyze that. So I'm going to click on data analysis. I'm going to do this without replication. Selected all this data and place that I want to put that. I say OK. So here is my p-value, or is my f-test. And this isn't quite as intuitive. You would have to go through some more tutorial of understanding how to read the data, but we went through the same thing with this too. Y'all didn't know how to read this the first time that you went through it. So it's just a matter of making a tutorial for this. But basically, here's the result of our f-test. Here's the result of the f-test here. So its f-test score is 92. This has an 85. Why, I don't know. I would guess the SPSS is more powerful and is better at doing this. But nonetheless, here's our significance level. So it's just like this. This is a negative, or it's not negative, it's a 0.022027. So the next thing that we want to do, just like over here, we made a comparison with post hoc analysis. Well, we want to do the same thing here. And there's a couple of ways that we could do that. So if you remember back to the first part of this class, I said one of the reasons we don't do multiple t-tests is because we introduce error in that. That's why we have this ANOVA. But once you determine there's a significant difference, you actually can go back and do 2 t-tests. You just have to do the Bonferroni adjustment, which is what this is right here. So the Bonferroni adjustment, basically what that means is you take the significance level that you determine is your cutoff and you divide it by the number of groups that you have. So this is kind of like a cooking show. I've already got one of these done. So my Bonferroni adjustment would mean I took my alpha levels of 0.05 and divided by 3 because I've got 3 groups. So now this is my criteria. Oops. So I want to run a t-test comparing these two things. So I'm going to go to data analysis. I'm going to scroll down here. 2 samples, assuming equal variances. Hit OK. So the first range is I'm going to use this group. So I'll put that here. Try that again. And my second column is here. And I need to decide where do I want this. I want to put it right there. And hit OK. So now it does a t-test for me. And it is comparing variable 1, variable 2. There is my one-tailed t-test. So now I've got to see if there's a difference between this one and this one. So I'm going to do this again. So I'm going to compare midterm. Yeah, it keeps going in the wrong place. I want that there. To this. And where do I want that? I want that right there. Hit OK. Now, there's my t-test. And now I need to compare number 1 to number 3. So data analysis, same thing. Clear these out. So this is number 1. Let's see if I put it in the right place. I did. And this is number 3. Put that there. So you got to pay attention to this thing. Okay, here's 1 to 3. Now it's not keeping up with your labels. You'd have to keep up with that. So this is 1 to 2. This is actually 2 to 3. And this is 1 to 3. And that number is less than 0.05. So the other thing that it can do, that's one way to do it. So I've already run this through. So this is using the data analysis format. This down here is another way of doing a t-test. And all this is showing, if you look at my cell up here, is I'm telling it I want this number in this box to be a t-test with column B and column C. And these 2 numbers tell it the kind of test and whether it's one tail or 2 tails. So this is number 2 is a independent t-test. This 2 means 2 tail. If I put a 1 is 1 tail. That's not what I did. This box, all it's doing is it is comparing this number to this number. So if you look at this indicator, I put it, and I have to write this out. I put if this number is less than or equal to this number, tell me yes. And if it's not, tell me no. And then I just copied and pasted all that. And then I had to do a chart. So here's the question. This is obviously a lot more steps there's a lot more chance you're going to, I think, to make a mistake as opposed to SPSS. You're just running a test. You tell it the test to run, and it does all of this for you. But you don't have access to this forever unless you go buy it. And it's like we said, it's expensive. So my question to everybody at this point is, are we better off as a program keeping up with the SPSS and teaching people how to do that, even though it's a little more expensive and you may have an issue of being able to find it down the road? On the other hand, in my opinion, it's easier to operate. Or would you rather learn how to do this with something you already have access to and could do forever, assuming, of course, that you have access to quality tutorials and information to explain how to read all these numbers, how to interpret them, and how to write them up. So I'm going to post this and provide a place for you to put questions. And if you would email me back and give me some feedback on which one of these, if we need to switch, would we want to do that? Is one better than the other? Do you see a value in being able to do this, not only just in the EDD program, but on beyond the program? And as far as I can tell, this data analysis, it will do everything that we need it to. It may not do the non-parametrics, but there's another one called a stat pack that does, and it's $100, and you can put it on your computer. So I'm gonna look into that some more, but we need to start here. So if you would give me that feedback, I'd appreciate it. Thank you.